Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
Welcome, everyone, to today's deep dive. I mean, if you're someone who really wants to stay ahead of the technology curve, but, without completely drowning in info overload, This is exactly where you need to be.
Oh, absolutely. The amount of noise out there is just staggering lately.
It really is. But today is Sunday, March 29th, 2026, and we have a seriously fascinating article to dig into. It's from the AI World Journal, written by Sydney Armani.
Yeah, the piece is called Google's TurboQuant Breakthrough, a turning point for AI memory efficiency.
Right. And, well, okay, let's unpack this.
Yep.
Because for years now, the absolute mantra of the entire AI industry has been, scale is everything.
Right, bigger is always better.
Exactly.
Yeah.
You want a smarter AI, you just build a bigger model. You buy 100,000 more GPUs.
Yeah.
It was all about raw intelligence. But this source reveals this quiet, honestly monumental shift. We're moving from that era of raw intelligence into an era of sustainable intelligence.
Which is huge. And I know for you listening, things like memory efficiency or quantization, they might sound like deep technical jargon.
Yeah, it sounds a bit dry at first.
Right. But you should really care about this, because this is the fundamental economic bottleneck right now. It dictates exactly how fast, how cheap, and how capable the AI tools that you use every single day are going to become.
So if this bottleneck doesn't break, the whole AI revolution just sort of stalls out.
Basically, yes.
Okay, so before we can truly appreciate the breakthrough of TurboQuant, we have to understand why AI is currently, breaking the bank. Just trying to remember what you said to it 5 minutes ago.
Yeah, the hidden cost of conversation.
Exactly. Or what engineers call the KV cache problem.
The key value cache. This is really the heart of the issue. When you interact with an AI over a long session, say you're having it write a complex legal analysis or, a marathon coding session.
Right.
The AI doesn't just look at your last prompt. It has to retain the entire history of that dialogue so it stays coherent.
And it doesn't read English the way we do. It takes your words and essentially puts them through a shredder. It breaks words down into fragments called tokens.
Yep.
And then it turns those tokens into vectors. And vectors aren't just like simple numbers. They're these massive, complex coordinates representing the underlying meaning.
Exactly. And the AI has to store all of those vectors in this KV cache, which is its active working memory.
Right. And to store those vectors, the industry standard right now is something called 16-bit floating point precision, or FP16.
FP16, yeah. Which is highly accurate. I mean, it captures a massive amount of detail, but it is exorbitantly expensive computationally because every single token isn't just one number. The AI is tracking thousands of tiny attributes.
The hidden dimension.
Exactly, hidden dimension size, just to define the exact flavor of a single word.
So imagine you're going on a hike.
Okay.
And every time you take a step, which in this case is the AI processing a single token, someone just drops a 16-pound bowling ball into your backpack.
Oh, wow. That is a perfect way to visualize it. Because if you just take a 10-minute walk, like a short prompt, you're fine.
Right, you can carry a couple bowling balls.
But the longer the hike goes on, the longer the conversation, the heavier you become. You just slow down.
You need exponentially more energy just to take the next step.
This raises an important question, though, because the math here isn't just simple addition. It compounds aggressively.
Oh, right, because of all the dimensions.
Yes, you have that 16-bit precision multiplied by thousands of tokens, multiplied by thousands of hidden dimensions. You suddenly have this exploding memory footprint that literally maxes out the physical RAM limits of the massive supercomputers running it.
The GPUs and TPUs, which means long context AI, becomes economically impossible. Like if a startup has to rent $1 million supercomputer just to let you have a 2-hour conversation without it forgetting your name.
They go bankrupt immediately. Not to mention, it completely prevents the idea of green AI.
Oh, because of the power consumption.
Right. The sheer electrical energy required by these data centers just to keep those 16-pound bowling balls suspended in active memory is just staggering.
So if we can't afford to just keep buying bigger backpacks, and we can't build infinitely larger data centers, we have to shrink the weight of the bowling balls.
Exactly.
Which brings us to Google's TurboQuant.
This is the shift. The brute force era ends. and the precision era begins.
The stats from the AI World Journal piece are honestly mind-blowing. TurboQuant takes that 16-bit precision and crushes it down to about 3.5 bits.
Yeah, 3.5 bits.
That is a massive 4.5x reduction in memory usage, 4.5 times lighter.
It's an absolute phenomenal feat of engineering.
But wait, I have to push back here. Because surely you can't just delete over 75% of the data and expect the AI to stay smart, right?
I would think so, yeah.
Like, doesn't just get severe amnesia? What happens to the nuance, sarcasm, technical medical jargon? If you chop down the numbers that drastically, doesn't the AI just start hallucinating?
That is a very valid concern, and that's exactly what would happen with traditional compression. Because transformer models are incredibly sensitive. Even tiny degradations in that KV cache lead to what researchers call attention drift.
Attention drift.
Yeah, the model literally loses focus on the core meaning of the sentence and just starts spewing nonsense.
So how does TurboQuant shrink it by 4.5x without breaking the model's brain?
Because it uses what Google calls learned quantization.
Okay.
It is not like zipping a file on your computer where you just blindly compress the whole thing. TurboQuant is smart. It uses selective compression.
Selective compression. So it knows what to keep.
Exactly. Imagine standard LP16 memory is a massive, high-resolution 4K photograph of a stop sign. It takes up a huge amount of hard drive space.
Right. You can see the rust on the pole, the texture of the red paint.
Yes. But if the AI's only goal is to know whether it should stop the car, it doesn't need the 4K rust data. It just needs a simple sketch of a red object.
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Octagon. TurboQuant turns the 4K photo into a sketch. It aggressively compresses the redundant data, the noise, while maintaining the critical signals at high fidelity.
Oh, wow. Okay, that makes sense. But how does it know it's a critical signal and what's noise in human language?
Well, think about a sentence like, "The extremely quick brown fox jumped right over the very lazy dog."
Yeah.
The AI realizes that words like extremely or very are low-value noise for its reasoning. It compresses the math for those down to almost 0 bits, but it keeps the core structural words fox, jumped, dog at maximum fidelity. It aligns with the AI's own attention sensitivity.
So completely avoids the semantic loss. It just drops the fluff.
Precisely.
Okay, here's where it gets really interesting. Because compressing memory like this doesn't just save space, it entirely rewrites the physics and economics of how AI data centers operate.
Oh, the system-level ripple effects are massive.
The source outlines some immediate impacts. First, latency optimization. Less data to move means everything goes faster.
Right, no more awkward 2-second pauses when you talk to a voice assistant.
Exactly. Real-time assistance.
Yeah.
And in finance, high-frequency trading algorithms can react in microseconds because they aren't choking on memory bandwidth.
And that speed leads directly to cost compression. If you reduce the footprint by 4.5x, a single GPU can suddenly serve far more concurrent users.
Like 4 or 5 times as many people on the same hardware.
Exactly, which forces a global repricing of AI services. It becomes vastly cheaper.
And then there's the long context reality. We always see marketing demos of AI reading entire books, but it usually crashes.
Right.
With TurboQuant, 1 million plus token contexts become a practical reality.
Right, you could feed it a decade of legal case files and it just holds it all without breaking a sweat.
But if we connect this to the bigger picture.
The green AI angle.
Yes,
Mm-hmm.
because AI data centers are so power hungry.
They are, and people often don't realize that high bandwidth memory consumes massive power just moving data around.
Right, just shuttling those bowling balls back and forth on the motherboard.
Exactly. By lowering this footprint, you drastically reduce data movement, which drastically reduces carbon emissions. It is a profound win for sustainability.
Okay, so hearing 4.5x smaller memory, it is super tempting to assume, great, I'm going to have a massive data center AI running natively on my smartphone tomorrow.
Yeah, that's the immediate thought everyone has.
But the article actually throws a lot of cold water on that edge AI hype.
It does. We really need a reality check here on what TurboQuant doesn't solve.
Right. It definitely helps local models, like the 7 to 13 billion parameter ones, run better on phones. But mobile chips, the MPUs, they still fundamentally lack raw compute power.
Yeah, the engine is still small, even if the fuel is lighter.
And your device still has to physically store the model's actual brain, the weights on its hard drive. Plus the thermal throttle issue. Sustained AI generation creates immense heat.
Right, your phone would just turn into a frying pan.
Exactly. So if smartphones aren't the big winner here, what is?
The true winner is agentic AI, autonomous agents.
Oh, wow. Okay, explain that.
We're shifting away from AI just being a chatbot that generates a paragraph of text. We're moving toward agents that do multi-step work over days, completely autonomously.
Like assigning an AI to code an entire video game over a weekend.
Exactly. On day one, it builds the physics engine. On day two, the lighting. But without massive memory, by day two, its KV cache fills up, it forgets the physics engine, and the whole thing crashes.
Right, the mission fails.
But TurboQuant provides exactly the robust working memory these agents need to not crash or forget their mission.
It's like giving an autonomous worker a flawless infinite notepad, so they can track a multi-day project without ever losing the plot.
That infinite notepad changes everything for autonomous digital labor.
So zooming out, we are witnessing a shift from just a technical innovation to a total realignment of industry power dynamics, the architecture wars.
This is massive. The old equation, more compute equals better models, is breaking under its own weight. The new frontier is better efficiency equals scalable intelligence.
So efficiency is the new moat.
Exactly. Smaller players can actually compete now on optimization rather than just brute force budgets.
And the hyperscalers, Google, Microsoft, NVIDIA, they're fighting infrastructure wars now, right?
Yes. They want to control the full stack, from custom silicon chips to quantization algorithms like TurboQuant.
And the source makes some wild predictions for the next 3 to 5 years about human-like memory systems.
Yes, what's fascinating here is how AI memory is becoming hierarchical, literally mimicking the human brain.
Let's break that down. So there's going to be sensory memory for immediate input, then working memory, which is this newly optimized KV cache,
Right.
and then long-term memory using vector databases.
Right, like an external filing cabinet, it can query when needed. But to make this work, it has to do dynamic memory pruning.
Meaning it actively decides what to forget.
Yes, it mathematically scores the relevance of every concept. High relevance stays in working memory. But as topics shift, older concepts naturally decay and get archived or permanently deleted.
Wow. So what does this all mean? It means the AI isn't just getting smarter, thanks to TurboQuant, it's getting sustainable.
Right.
We are moving away from an unsustainable brute force arms race into an era where AI can think further on significantly less energy.
Exactly. And the takeaway for you, listen, is that the next time you notice your AI assistant flawlessly recalling a complex detail from an hours-long conversation, you are witnessing the magic of selective compression at work.
But understanding this dynamic pruning leaves us with a really provocative question to ponder. If future AI systems are dynamically pruning and strategically forgetting data to build this human-like hierarchical memory, who decides what gets forgotten?
Oh, that's the ultimate question. What algorithm decides what is irrelevant noise?
Right. And could an AI eventually develop the equivalent of a repressed memory just because a topic was scored as low relevance at the time? Or could it develop nostalgia simply based on the weight its quantization algorithm gave to a past conversation?
It really makes you look at these systems in a completely new light.
It does. Thank you so much for joining us on this deep dive. Until next time.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.